Welcome to another unit in this preparatory course Mathematics. This time I'm going to talk about exponential equations. Exponential equations, that's an equation where the variable x we are looking for is part of the exponent. So what we have to do, we have to actually get to this exponent, and we can do this by using the logarithm. So we logarithmize both sides of our equation. So for example, if we have something here as 5 to the power of x being equal to 25, we want to get the x, so we need to get rid of the 5 to the power of. So here we can use a logarithm. Easiest version, use any type of logarithm, for example the natural logarithm. So apply this to both sides of the equation. Then on the left side we have ln of 5 to the power of x, and on the right ln of 25. Then we can use the logarithm rules where we can pull the exponent in front of the logarithm. So instead of ln of 5 to the power of x, we get 5 times ln of 5, x times ln of 5. Then, well, we simply divide by ln of 5, and we get ln of 25 divided by ln of 5, which is 2. So the x we're looking for here is 2, which obviously makes sense if we were to insert this again in our equation. So this was the first example. Then, if we take a look at the second example, which here is slightly bit more complicated because we have an exponential term on the left and on the right. So if before we could have just used the logarithm to a specific base, this will no longer work here because we have two different bases. But we can still apply the same rule as before. So on both sides, for example, the natural logarithm, which we did here, then again pull the exponents in front of the logarithm. So pull the x minus 1 on the left and the 2x on the right in front of the logarithms. Then it looks as here. Well, then this is, even if it looks a bit strange, but ln of 3 and ln of 4 are simply numbers. So what we now have here is nothing else than a linear equation. And well, with linear equations, what we did is get everything which contains an x on one side and everything that does not contain an x on the other side. So first we factor out, then we have x times ln 3 minus ln 3 equal to 2x ln 4. So we bring everything with x to one side, all the other stuff to the other side. Then looks as here. And finally, we can simply factor out x and divide by the big parentheses after the x. So divide by ln 3 minus 2 ln 4, giving us here a solution for x of ln 3 divided by ln 3 minus 2 ln 4, or if we put this into a calculator, minus 0.656. So the idea always is apply the logarithm on both sides, extract the exponents, write them in front of the logarithms, and then simply solve it as a linear or other type of equation. Well, that's relatively straightforward, and that's already everything there is to be mentioned about exponential equations. So I say goodbye and see you next time.